So fine, yes, we have discussed about the chapter light, right? And there we have been introduced with two topics or two major concepts, that was reflection and refraction. Okay, and we have come across two optical devices that we make use of. Which are they? When you're considering reflection, you know there are mirrors, spherical mirrors and plane mirrors for you. Plane mirror is also a spherical mirror. And you have refraction where you make use of lenses. And we have discussed about the power of a lens and what is a magnification, etc. Okay, so we are being ready with the concepts now. Now let's see how far you are clear about the concepts through discussing some questions here. Okay, you know that at this point of time you are having MCQs and assertion type questions and also case study for your exam, right? So we will be introducing to you some questions related to these sections so that you will be aware of how to deal with such sort of questions. Okay, so that is the aim of this particular session as such. Okay, so let's see how far you're clear about the concepts. Here I have the first question. So first set of questions will be state MCQ level questions. Then we'll be moving on to assertion reason type questions. And finally, we'll deal with some case studies. Okay? Straight MCQs, you know, you just have to read the question and you have to pick out the answer from it. That's it, nothing more, nothing less, right? So let's see the first question. In which of the following mirrors, image of an object is always virtual, erect and smaller in size than the object? Okay, so this is the question. You have four options out here: convex mirror, concave mirror, plane mirror, or may not be all these. Okay, so what do you feel? I want your answer to be dropped in the chat box. Okay, you can point the option number A, B, C or D for this question. Okay, so I would like it to be 1A, 1B like that. Okay, question number 1, the option A, B, C or D, either of these. That's how you have to drop it in the chat box. Okay, so now tell me, I have A from Fatima, Anushka, Neha, 3 options with A. Okay, anyone else with any other answer? I think it's a no. Only 3 of them. Okay, Avantika again with A. Anyone else? I have 4 votes for A. Yes, Mohammad Khalifan, right? Tirtha. Okay, all of them are behind. Okay, Charles. All of them are behind A only. So many votes for A. Now I can't count it. Fine. So again, since all of them are behind A, then let me also come with you. Yes, it is convex mirror, right? We know that if it is a convex mirror, then the image will be formed at the back of the mirror, okay, by the extrapolating of the rays, right? And thereby we can say that is a virtual image and that is an erect image since it is a virtual image, right? And we get to know that they are smaller images too. So the answer will be obviously convex mirror. Okay. Now let's see the second question. The linear magnification produced by a convex mirror is always positive. This is because we say that for a convex mirror, M is positive. Okay. Why? So write it to be, please mention the question number, then write your option. 2D from Fatima Hasna. 2D again from Yusuf. Okay, Neha again with 2D. Anushka with 2D again. Nishka with 2D. Sorry. Yeah, Nishka. Tirtha with 2D. Leah with 2D. So many vote for the same. You don't have any other options to me? noted? No? Okay, Vaiga with D again. So, what is the question? We have mentioned that the linear magnification by a convex mirror is positive. Okay? And yes, it is because it is forming always a virtual and erect image. Okay, yes, Charles, I do note your answer too. Okay, so thus I can say that I also support your answer. Yes, it is because the image is formed by the convex mirror are virtual and erect, and that is the very same reason why we make M to be positive. Okay. Now, let's see the next question here, the third one. The focal length of a concave mirror that produces 4 times larger real image of an object held at 5 centimeter from the mirror is. Okay, so you have a numerical here, and the focal length of concave mirror is 4 times larger real image of an object held at 5 centimeter from the mirror. You have two values, 4 times, what say, a clue is given that it is 4 times larger. So, you have to see what that signifies, whether it is the image distance, object distance, whether it is focal length, whether it is magnification, anything that you have to find out. Then the object is held at 5 centimeter from the mirror. Okay, so you have two values specified or two clues given. From this, you have to find out what is the focal length of this concave mirror. Okay, so try and do it. Please do mention your answer with question number. Write it to be 3 and something. Okay, I'm moving aside. You can see the options clearly. You can see the question also very clearly, I guess. Mention the question number and then the option. Okay, 3A, 3B, 3C, 3D likewise. You got the answer? Okay, so let me support. We want to find the focal length of the concave mirror, right? And if you want to find the focal length of a mirror, what is the equation to be used? It is the mirror formula. 1 by f is equal to 1 by u plus 1 by v, right? So, this is the standard equation that we know. Okay. Now, here you have u because it is given that object is held at 5 centimeter from the mirror. And we know that the distance between object and mirror is the object distance u. And that is given to be 5 centimeter. And since we know the object distance will be negative because it is mentioned from to the left of the mirror. So, that will be negative value by sign convention. So, substitute that. And the other portion that is given is the 4 times larger image is formed. That means magnification equal to 4. And that will be minus 4. Why? Because it is a concave mirror. So, the magnification will be minus 4 here. Okay. So, these are the data you have. And you want to find f. Okay. So, first you need to find v. Then only you can find f. Okay. And for that, I can make use of these two data. So, how is that possible? You have an equation for magnification. What is that? It is m is equal to minus v by u, or rather v is equal to minus mu. Right? So, substituting the value for m and u, it will be minus 4 into minus 5, that is 4 into 5, 20 centimeter. Okay, and you will be having a positive value because there is already a minus in the equation and you have magnification to be -4, making it 20 centimeter. Okay, and there is a minus here. Okay, so when you substitute that into this will be minus 20 centimeter. Clear? You already have negative values for m and u. So you have put -4 and -5, and there is a minus already there. So substituting that, you will get v to be minus 20 centimeter. Now you have to find the value of f. Okay, so that would be what? It will be 1 by f is equal to 1 by minus 20 minus 1 by 5. I have substituted the signs too, see to it. Okay, so whenever you have a numerical, you are supposed to give it the proper sign conventions too. Okay, so substituting it, you will get it to be what? 1 by 4, right? There will be 5 minus minus plus 20 divided by minus 100. So making it to be minus 1 by 4. So 1 by f is equal to minus 1 by 4, right? So what will be f? F will be minus 4 centimeter, making it option C. Okay, so that will be the value. Clear? So whenever you are dealing with a numerical, especially in terms of light, see to it that you are substituting the values along with the proper sign. That is a very must thing. Then only you will get the correct value. Okay. And when you are substituting for equations like mirror formula, you have substituted and find out the value for 1 by u plus 1 by v. That was 1 by 4 minus 1 by 4. But that is a value for 1 by f. Okay. And you want the focal length and not its reciprocal. Right. So whenever you have to find like this, please do remember that you have to take the reciprocal of the final answer. Okay. At times you make mistakes in such cases. That's why I'm repeating it. Fine. So we shall move on to the next question now. The magnification of a concave mirror is -1. What is the position of the object? Okay. The magnification is given to be -1. So from that you have to analyze where will be the object. Okay, so -1. If -1 is the thing, then okay, I've started getting the answer. One option, one vote for C, that is from Fatima Hasna. Any other option? Anyone? No one else want to try? Just think, there is a minus value. The value is given to be 1 as magnification. That is, m is given to be -1. If it is minus, what does that indicate? If it is 1, what does that indicate? Think like that and get into an answer. Okay. So since I am not getting any more options, let me say, yes Fatima, very good, you are right. Okay. Alok with option B, that's okay. But the option is C actually. Why? Because we have m to be negative. What does that indicate? If it is negative value, it indicates that the image formed is real and inverted. Okay. And the value is given to be 1. Right? So what does that mean? Magnification is 1 means height of object and height of image are same. Then only the ratio will give you the answer to be 1. Right? So that means what? 1 indicates that it is of same size as that of the object. Okay? So we have two concepts here. It is a concave mirror, and when the object is placed at a particular point, the image formed is real, inverted and same size as that of the object. And for that to happen, the object should be placed at C. Okay. So this is how you have to analyze. Yes, I can see the options from Vaiga too. Okay, so this is how you have to analyze a particular concept based on magnification. Clear? Now let's move on to the next question, that is, a virtual, erect and magnified image can be formed by. Okay, you want a virtual, erect and magnified image. Okay, for that, I should make use of which of these lenses? And see to it, they are lenses and not mirrors. Don't get confused with both of it. Okay, don't just go for the question. Go for the suffix along with the value, along with the option given. They are lenses and not mirrors. Till now, we were dealing with mirrors. That's why. Okay, I have one vote for B, concave lens. Anything else? Anyone? Nishka with 5B, Tirtha with B, Diya with 5B, Remo with B, Fatima Hasna with B, Vaiga, Tirtha, Yusuf, everyone is behind B, I guess. Neha again. Okay, so on that note, okay, Diya is correcting it to be A now. Okay, so one vote is getting over there. Okay, now Alan is behind B again. Fine. I think no more options are there. Fine. So, yes, Diya, even if it is late, you said the right thing. Even though you made it wrong first time, you made it correctly, you corrected it. Yes, it is the convex lens. Please do remember that convex lens is giving you images similar to concave mirror. Okay, and concave lens is giving images similar to convex mirror. They are acting reciprocally. Okay, if you have that such a comparison in your mind, then it is very easy for you to understand or grab the image positions. Okay, and whenever you have such reciprocal ideas of or notations, then please do study only one thing. Okay, say if you have to analyze the differences between two different objects, okay, and you have one particular thing where it is possible, the other one is it is not possible. Here it is not there, the other one will be it is there. In such cases, always study one thing and just remember that the opposite is the other one, so that you will not get confused. That's just a tip. Okay, whenever you have two things to be learned with the comparison, then always learn one particular thing. If the other is having the opposite of the first one, on that note, always learn only one. Okay, if you want to focus on mirrors, then focus on mirrors only. Don't by heart the positions with respect to lens. Okay, don't by heart that table because you will get confused. Okay, so always study mirror or always study lens. Okay, and see to it that the reciprocal will be acting on the other one. Okay, if you have concave mirror and its image positions in your mind, then think that convex lens is also like that. Similarly, study convex mirror. There are only two positions in it. Convex mirror is sit in you. Okay, concave lens will be opposite to that. That's it. The image positions are same. The notations are same. The only thing is that there will be 2F, there will be 2C, C1, C2, F1, F2. That is the only difference made. And that you can analyze from the position. Okay. So, always have such a way of approaching things. Okay. So, yes, the answer is convex lens, which is equivalent to concave mirror, the variations in concave mirror. Okay. And we know that for a concave mirror, when you are placing the object between F and P, right, then you will be getting a erect, virtual and magnified image, highly enlarged, right. Similarly, for convex lens too. Clear? If it is placed between F1 and optic center, again you are getting a highly enlarged virtual erect image on the same side. Fine. So, that is how you have to analyze the lenses and mirrors. So, I hope that's clear for you. Let's move on to the next question now. An object is held at 10 centimeter from a concave lens of focal length 20 centimeter. The distance of the image from the lens is. So, this is your question. And whenever you have such questions to approach, always do either of one thing. Either when you're reading, going through the question itself, note down what all things are given, or else give a diagrammatic representation of it and analyze what all things are given. Okay. So, if you are going for a pictorial representation, you have a concave lens here, right? So, a concave lens is being taken, okay, just a rough diagram. An object is held 10 centimeter from a concave lens. So, an object is here, okay, and that is 10 centimeter from the mirror, fine, and the lens focal length is given to be 20 centimeter, and you want to find where is the image formed, okay. So, this is what you have to find out. Clear? So, on that note, you have U to be equal to minus 10, F to be equal to 20 centimeter, and you are asked to find V. Okay, and see to it that you have taken a concave lens, right? So, we know that U is already minus, and for a concave lens, F will also be minus value. Okay. So, substituting that, you will get the value. So, tell me what will be V. We know that 1 by V is equal to 1 by F plus 1 by U, isn't it? Because if it is a lens formula, the other one was mirror formula, here we have taken the case of a lens, and for a lens 1 by F is equal to 1 by U minus 1 by V. Okay. So, in that, 1 by V minus 1 by U. Okay. So, on that note, if you want to take 1 by V, then it will be 1 by F plus 1 by U. Okay. So, you have this particular relation. Okay. And by substituting and simplifying, you will get the value. I am not taking enough time. If you are substituting the values and you simplify, you will get it to be minus 24 centimeter, which is option D. Okay. So, I am not wasting time on calculation because you know the calculation part. It is just addition, subtraction and division. Nothing more, nothing less. Basic arithmetic calculations are there. So, moving on to the next question here. The focal length of a combination of convex lens of power 1.5D and concave lens of power minus 2D is. So, you have two lenses, one is convex lens and its power is given to be 1.5D, it is plus, okay. And you have another lens that is concave lens, and for that the power is given to be minus 2D. And you have to consider the combination of these two, and you have to find the effective focal length of that combination. That is the question. Okay. And you know that the power of a lens is reciprocal of focal length, right? And for that the focal length has to be mentioned or determined in terms of meter. Okay. So, if you get the effective power, then you can account for the effective focal length, right? Because we know that P is equal to 1 by F. Okay. So, I want to know the F, right? For that I need to have P. I have P1 and P2. All I want to find is P, and P will be nothing but P1 plus P2, right? And if you want to find P1 plus P2, then that will be simply 1.5 minus 2, right? And I have put minus because there is minus 2D as power for the second lens. Okay, it is actually 1.5 plus minus 2. That is why I written it to be 1.5 minus 2. And we know that this value will be minus 0.5 diopter. Okay, so that is the value of power, the effective power, or rather the total power of the combination of lenses. And now you want to find the focal length. Okay, and if you want to find the focal length, we know that power is equal to 0.5 or rather minus 1 by 2, right? And P is equal to 1 by F. So, this will be equal to minus 2, right? So, minus 2 will be the answer. And minus 2, focal length is given to be minus 2, right? So, you have focal length to be minus 2. Is that meter or centimeter then? Please do write in the chat box. Give me the unit of focal length here. I have got 0.5 diopter as the power, minus 0.5. Okay, it is centimeter, centimeter, centimeter. Fine. Okay. Centimeter again. But I would say it is meter. Because if you want to get power in diopter, focal length has to be in meter. Yes, as Anushka said. Yes, Yasin. Wasin. Okay. There is Tirtha who are given this answer. Fine, I have noted that. So, whenever you have power in diopter, then that means that focal length is expressed in meter. Okay, and you haven't done any energy, any unit conversion here. And if you wanted the value of focal length directly in centimeter, then you just have to substitute P is equal to 100 by F. That is fine. Because we know that focal length into 100 will give you the corresponding value in centimeter. Right? So, if you want to convert it as such, you can do this conversion equation directly. You don't have to do P is equal to 1 by F, then get the value and then to convert it into centimeter. Just do 100 by F. That will give you the direct value of power. Okay. So, that is how you have to consider the equations. Oh, sorry. I mean to say the direct value of focal length. Okay. So, if you want focal length in centimeter, you can find this, or if you want focal length in meter, it is like this. Okay. So, please do check the units also, and whenever you are writing a numerical, please do mention the unit. Okay. So, whenever you have a numerical to approach, first and foremost, the initial step to be done is that the data should be supplied. Okay, so you have to supply the data given and check the units, and for numericals related to light, substitute the sign as such there itself. Okay, so if you have U is equal to 10 centimeter, write minus also there itself. Okay, likewise. Then after that, check for the equation that suits it. Okay, then rearrange the equation if needed accordingly, according to what you have to find out. If you want to rearrange the equation, then do that. Substitute it, get the final answer, write the unit. Okay, this is how you have to proceed. Okay, so that is the way you have to approach the numericals. Clear? And hence, yes, as Tirtha has already commented, the answer will be option C. Okay, so this will be option C because you have minus 2 meter. So, either it will be minus 2 meter or it will be minus 200 centimeter. Okay, so that's how the value goes. Now, let's see the next question here. If the refractive index of water is 4 by 3, the velocity of light in water is. Okay, so you have the refractive index of water given and you have to find the velocity of light in water. and you will definitely have one question based on refractive index for sure. So please do have a general idea and the in-depth concept related to refractive index. Then only you can solve these type of questions. Okay. So now let's check it out. Just go through the question and get me the answer. Okay, since I can't ask you for the questions or new equations as such. Okay, I'm getting answers like option C from Tirtha Diya. I don't know if there were anyone the upper portion, I can't see them. Okay, I have two options for them. Okay, Alan. Vaiga. Fatima. Premo. Vasin. Okay. Vasin is with option A. Fatima is also with option A. Eight A by Yusuf. Fine. So let me explain this. Then we'll get back to the options. So we know that the refractive index of water is given to be 4 by 3. That is N of W is 4 by 3. Okay. And according to the definition, we know N of W means velocity of light divided by velocity of light in water. Right? So you have velocity of light in air, rather vacuum, divided by velocity of light in water. Okay. And you are asked to find the velocity of light in water. That means this one. Okay. So simplifying it, I can write it to be C by VW. Okay. C is the velocity of light in air and VW, let it be the velocity of light in water. And if you want this value, then the equation turn up to be VW is equal to what? It will be C by NW. Okay. And we know that the velocity of light in air is 3 into 10 raised to 8 meter per second. Is that not so? And NW is given to be 4 by 3. So since this is divided by 4 by 3, I am writing it to be multiplication of reciprocal, that is into 3 by 4, making it 9 into 10 raised to 8 by 4. Okay. So 9 by 4 will give me 2.25 and hence the value is 2.25 into 10 raised to 8 meter per second as the answer. So option C is the correct answer. Clear? Okay. So most probably you might have done 4 by 3. Okay. So check with it whenever you are doing numericals. Now we have the next question. The angle of incidence of a ray of light is 45 degree. If ray travels from air to glass, find the angle of refraction. And the refractive index of glass, G is glass as it is mentioned here, it is material glass. So Ng is given to be 1.5. Okay. So angle of incidence is given to be 45 degree and you have to find the angle of refraction. The only clue given is that refractive index of glass is 1.5. So how can I proceed? You have any relation connecting angle of incidence, angle of refraction and refractive index? Don't we have the Snell's law, which says sine of the angle of incidence to sine of the angle of refraction is equal to a constant, which is n, refractive index. So, you have it for glass here and you want to find R value. So, if you want sine R, let's take sine R first. It will be equal to what? It will be Ng by sine I. Okay. I think the board is clear now. Fine. So, you want to find the value of, you have already given the value of Ng. Okay. So, oh sorry, I have written in the reciprocal way, I guess. It should be sine I by Ng. Yeah. So, you already have the value of I as 45 degree and Ng to be 1.5, right? So, this is sine 45 divided by 1.5. The value of sine 45 will be what? It will be 1 by root 2. Okay. So, substituting that, this will be 1 by root 2 into 1.5. Clear? And on simplification, you will get that to be something around 0.471. Okay. So, that will be the value you are getting. And that is sine R, and you want R, angle of refraction, right? So, that will be sine inverse of 0.471. Okay. So, that will be approximately around 28 degree. That was a random value. For your numericals, it will be standard values. Okay. Because the sine value will be like sine 30, sine 45, etc. Okay. For Dia, it's stuck in. Okay. So, is the same problem faced by any other persons? Is there any stuck or any network jam occurring in other areas? For other one? No. Okay. Ah, yeah, okay. It's okay now for Dia also. That's fine. Okay. Thank you. So, for you people, most of the time the equations will be the sign values or the value that you are getting will be almost in a what's a standard form. Okay, Dia, I'll get to know that. Fine. So, that would be okay for you. But this time I just thought of giving you another value. That's it. Now, taking the next question. An object 5 centimeter high is placed at a distance of 10 centimeter from a convex lens of focal length 15 centimeter. Find the magnification and size of the image. Okay. So, the first thing given is that the object is 5 centimeter high. That means height of the object is 5 centimeter. Okay. And it is placed at a distance of 10 centimeter from the convex lens. So, the object distance would be 10 centimeter. The focal length is given to be 15 centimeter. So, you have f to be equal to 15 centimeter. And you want to find the magnification and the size of the image, that is hi. Okay. So, these are the variables you want to find out. Clear? And you have height of the object, focal length and the object distance. Okay. Object distance is given to be 10 centimeter. So, that will be minus 10. Height of the object is given to be 5 centimeter, and you know that since it is above the principal axis, it will be plus 5 centimeter. And you have focal length to be equal to 15 centimeter, and it is a convex lens, so that will be positive again. Okay. Now, you want to find magnification as well as the value of hi, or rather height of the image. Okay. So, if you want magnification, either the equation is hi by ho or the equation is minus v by u. Right? If you want magnification with this equation, you don't know v. If you want to find magnification using this equation, you don't know hi. And that is another unknown. Okay. So, and HI and M has to be found out. So, you can never use this equation. The only possibility is using this equation. And for that, you need V. Okay. And in order to find V, you have a clue like F. Fine. So, you have the value of F, value of U, and you want to find V. Clear? And we know that we can make use of the length formula here. What does it say? It gives you 1 by F is equal to 1 by V minus 1 by U. Okay. Or rather 1 by V will be equal to 1 by F plus 1 by U. Fine. Substituting 1 by 15 minus 1 by 10 because there is minus over there. So, I have put minus instead of plus here. Okay. So, simplifying and taking the reciprocal. Okay. Please do consider that by taking the reciprocal, you will get it to be 150 by, okay, this will be minus 30 centimeter. Right. So, if you want to find the value of V, then that will be minus 30 centimeter. Okay. So, you got the value of A. Okay, I have got equations right now. So, most of them are behind option A, I guess. There is Diya, Vaiga, everyone is behind option A. So, let's check it. You have V to be equal to minus 30 now. Okay. And all of them are behind option A. Now, let's see what is the magnification produced. Fine. So, for that, I have to take M is equal to minus V by U. You have 30 and 10. So, making it 3 centimeter. Clear? So, you have the value of M to be equal to 3 centimeter. So, that is possible only by this. Okay. So, with that itself, you can analyze that it is option A. But let's check whether the value of height of the image is same. Okay. For that, what I have to do? I have to make use of the other equation, which is M is equal to HI by HO. And in order to find HI, that is nothing but M into HO. M we got it to be 3 and HO is nothing but 5, making it 15 centimeter. Okay. So, now we got the value of magnification to be 3 and the height of the image, rather size of the image to be 15 centimeter, making option A to be the correct option. Okay. Now, till now we were dealing with straight MCQ questions. Okay. So, now you have straight MCQ questions. Now, we have another concept, that is assertion reason type questions. Okay. So, if you want to get assertion reason type questions, then there will be one statement given as assertion and there will be another statement given as the reason for it. Okay. So, first you have to check whether the statement given as assertion is correct. The statement as such is correct or not. Then you have to check the statement given as reason. The statement itself is correct or not scientifically. Then you have to check if both of them are correct. Then check whether the reason is supporting the statement or rather is the statement explained by the reason. Okay. If so, I can say it is option A. Or if both of them are correct but not explaining the assertion, then option B. Okay. Likewise, you have to analyze. So, there is 4 possibilities. Either A and R are correct and giving correct explanation, or option B, A and R are true but R is not the correct explanation of A. Then there is C, where A is correct and B is false, sorry, R is false, and option D says A is false and R is true. And at times in certain question papers, we get to see that A and R both are true as the option D. Okay, so see to it what is the option given. Don't just randomly start giving the answers. Okay, at sometimes in some question papers you get to see that for option D instead of this they may write both are wrong. Okay, so now let's check it out. What is happening? The first assertion given is that a ray passing through the center of curvature of a concave mirror after reflection is reflected back along the same path. Okay, and the reason given is that the incident rays falls on the mirror along the normal to the reflecting surface. Okay, so that is the answer given here, or rather the reason given here. Clear? So you have a ray passing through the center of curvature of a concave mirror. After it is being reflected, it is reflected back along the same path. And it's true, right? We know that when a ray is passing through the center of curvature, it is retracing its path. Okay, so assertion is correct. It is a correct statement. Now let's see the reason. The incident ray falls on the mirror along the normal to the reflecting surface. Again, that is also true. And that is why it is retracing the path too. And because of the same, I can opt for option A. Okay, that is how you have to check the assertion. Now let's see the second question here. Okay, so from this onwards, you will be giving the answers. I won't be giving the answers. Okay, so the first one is assertion. Light does not travel in the same direction in all the media. Okay, and the reason given is that the speed of light does not changes as it enters from one transparent medium to another. Okay, so that is how it is given. Now you have to find what will be the answer, and please do write it as 12A, 12B, etc. Okay, I have already started giving the options, I guess. Many of them are with option C. That means you are saying that assertion A is true and the reason is false, right? And I do agree with you people. Yes, it is option C, because we know that light is not traveling in the same direction all the media, right? It is not a unidirectional thing. And when you consider the reason, it says the speed of light does not change, then that is not possible. Because of the change in speed, only the refraction is happening, the bending is happening, right? So that is a wrong statement. Clear? And making it A is true but R is false to be the correct option. Clear? Now, the next one would be, assertion is that a ray of light traveling from a rarer medium to a denser medium slows down and bends away from the normal. When it travels from a denser medium to a rarer medium, it speeds up and bends towards normal. Okay? Now, reason given is that speed of light is higher in a rarer medium than a denser medium. Now, check it. Okay, 13D, 1 vote. With Dia and Jersha also with D. Neha also with D. Vaiga with D. Remo with D. Alan with D. Abhinav with D. Anushka with B. With D. Nishka, okay. All of them is behind D then. Hari, Tirtha, everyone. Yes, that is correct. Right? So, it says what? A is false and R is true. We know R is true. Okay? But a ray of light traveling from rarer to denser medium. What happens to that? When it is from rarer to denser medium, then it will bend towards the normal. And if it is from denser to rarer medium, then it is away from normal. You can use this mnemonics to remember this. Okay, if it is from denser to rarer medium, then away from normal, DRAN. And the vice versa will be the other one. That you can just think of it. You just learn this. As I told you before, don't learn like from rarer to denser, bending towards normal. From denser to rarer, bending away from normal. That will give you a confusion when you are in the exam hall. Now you will be clear with the ideas, and when you are into the exam hall and when you start writing with your pen, you will be having a confusion whether it was away or whether it was towards. That confusion will remain there. So for that, always use either some tricks or any other mnemonics, or do as I told you, just learn one thing. Okay. Now, you have the next question, that light travels faster in glass than in air. Reason given is glass is denser than air. Now, you have to give me whether it is correct or not. You can start giving the answer. Okay, D. Anushka, Abhinav, Dhurta, Niradha, Nishka, Alan. Everyone is the option D. So many votes for D. Okay, I do accept it, because light travels faster in glass than air. That is not possible, because glass is a denser medium. That is true. And since glass is a denser medium, the velocity is less there. Okay, so it can't move fast, it will be slower. So assertion is false and reason is true. Clear? So it is option D. Now moving on to the next question. Assertion is that mirror formula can be applied to a plane mirror. Okay, and the reason given is that a plane mirror is a spherical mirror of infinite focal length. Okay, so this is the assertion and the corresponding reason. You have to find the correct option with your question number. Please do mention with the question number. C. 2 votes for C. 3 votes for C. No other option or no other guess? No one else want to vote? Just 3 of them, the others? 15C again by Remo. Neha, Vaiga. Yusuf. Vaiga is with D now. Okay, so let me say, mirror formula is applicable for spherical lenses or spherical mirrors. Okay, so mirror formula can be applied to a plane mirror, because plane mirror is a spherical mirror of infinite focal length. Okay, so as focal length increases, the curve or rather the aperture decreases. Okay, so as f increases, what happens? It will be like this. Okay, so the curves get reduced, the aperture gets reduced. So it is a spherical mirror with infinite focal length. So plane mirror is a spherical mirror. So reason is correct. Okay, and that is why, since plane mirror is a spherical mirror, we can apply the mirror formula to plane mirror. Okay, so the option is A. Clear? Now, the assertion is that the height of an object is always considered positive. The reason is that an object is always placed above the principal axis in the upward direction. Why sorry, Ellen? Oh, you've already started applying. It is option A for all. Right? Okay, so I don't think any explanation is required here, because we know that height of object is always positive, because the image is always, object is placed over the principal axis, right? So it is since it is above the principal axis, it is positive. Okay, that is clear. So it is option A. Now let's check this question too. Assertion: concave mirrors are used as makeup mirrors. Reason given is that when the face is held within the focus of a concave mirror, then a diminished image of the face is seen in the concave mirror. So what do you think about this? Concave mirrors are used for makeup mirror, and it is because you are getting a diminished image. Okay, all of them. Diya with 17, C. Okay. Tirtha with C again. Nishka with C. Nirada with C. Alan with C. Vega C. Neha C. Okay. Nisha. Okay, everyone is with C, I guess. Right? Okay. So, yes, I also go with C because makeup mirrors, the concave mirrors are used as makeup mirrors, but they are forming enlarged image and not diminished image. Clear? So, that's it. I'm winding up the session for now since we are done with the time. So, please do study well, by heart the concepts, don't just by heart the concepts. Just go through it, get a clear-cut idea about the concepts, evaluate it, analyze it, and then answer the questions correctly. Okay? So, that's it guys. Thank you. All the best for your exams.